All right, class, we're continuing the electrical unit. I want to show you some of the materials that we use for electrical circuitry and wiring. Now remember, the goal of this unit is to teach you some basic fundamental skills and knowledge about electricity and electrical wiring. So over the next few weeks, I'm going to be showing you several different wiring exercises that you could use later in life to wire basic electrical circuits. Now, I will tell you, after this unit, you're not going to be a trained electrician. That would be something that you need to seek further training on. But you will have some basic knowledge, some basic skills that you could do some very fundamental wiring circuits in your house or later in life. We use these circuit boards, and each circuit board has 3 electrical boxes. And per National Electric Code, all electrical connections need to be inside an electrical box, and that's for fire and shock prevention. So we use these boards to replicate what it might look like to wire a circuit in a building or a structure. You're going to be using several different materials, or you're going to be observing several different materials while we continue to work through these wiring exercises. So one would be a duplex receptacle, and you all have seen a duplex receptacle in your house. It's a way to get energy in the form of electrical current to appliances or tools that you need to use. And then we have a couple kinds of switches here. Now this switch is a standard single-way switch, on and off. Power comes in. If the switch is on, power goes out. If the switch is off, the electrons stop moving. It's an open circuit. This type of switch, some of you might have in your home, it's called a 3-way switch. So how this switch works is power comes in, and it can either take 2 paths. It can go this way or it can go this way. And these switches are used fairly often in a hallway, where at the beginning of the hallway you turn the light on, you get to the other end of the hallway, you want to turn the light off. There's 2 switches controlling 1 light. And then speaking of a light or a lamp holder is another device that I will teach you how to wire. Some of the tools we're going to be using wire strippers and crimpers, and then just some pliers, some cutting pliers, diagonal cutting pliers, just to cut wires today. Now let's talk about wire. This is non-metallic cable, and you can buy non-metallic cable in a lot of variations, depending on the gauge of the wire, or the thickness of the wire, depending on how many wires are inside. But this is a very common material used in structures for electrical circuits. Commonly called Romex, but it's non-metallic electrical cable. And the electrical cable that we're going to be working with, you've got 4 wires. Now the wires themselves are all the same. They're copper wire. Copper is a great conductor of electricity, and these are 14 gauge. So 14 gauge wire, the gauge is the thickness, and they're made of copper. Now you notice, however, they are covered with an insulator, and that insulator is plastic, and we use the plastic color as a code. Each color tells the electrician what that wire is being used for. So this wire here that's bare copper, is the ground wire. And grounding is a safety measure that electricians use to get rid of unused electricity in the system. So if you walk around your house, you're probably going to find your electrical service panel, your entry panel, and coming out of that panel should be your ground wire or cable going to your ground rod, which is going to go deep into the ground, and it gets rid of any unused electrical current. The white is the neutral. Electricity flows in a complete loop. So if it goes out to the light, it's got to come back to the source. So that's your neutral or your return. And then red and black are used for hot wires. That's your delivery wires. That's taking the electrons, the electricity, to your device, whether it be a light or a duplex receptacle plug, whatever the device that you're trying to power would be. Okay, so what I'm going to show you today is how you would go about setting up your electrical boards. So you're going to run the cable from one box to the next, because remember, all connections have to be inside the box. So for that to happen, the wires have to come into the box. So there's these little tabs that you can knock out in the bottom of these boxes. By the way, electrical boxes aren't always plastic. Some are metal. They're not always rectangle. Some are square. Just depends on how many devices you're putting in the box. So you'd knock out these little windows and you'd pull your cable in. Now, per National Electrical Code, you need to have 6 inches above the box of Romex or non-metallic cable. So once you pull that wire and you've got your 6 inches exposed, you can cut. Now I'm going to set this up as if this is the power coming in. So this is our line coming into this circuit. And in most structures, you're going to have several different circuits, because you can only run so many devices on a given circuit before you overload. So we're just going to pretend this is coming from our power source. And then I would run my next cable from box 1 over to box 2. Now remember, how many inches do we need exposed out of the box? 6 inches. That's right. So we measure 6 inches. Now we have to measure 6 inches here too. Okay, so now we have our wire running from box 1 to box 2. And lastly, we need to go from box 2 to box 3. Now this obviously is a project or a step that most of the time students do, but we don't have the opportunity to be in shop or at school right now, so I'm doing this procedure for you so that you can at least kind of experience what it might be like. Okay, so we've got our power coming into the circuit, into box 1. We've got a cable going from box 1 to box 2, and we've got a cable going from box 2 to box 3. So we've pulled our wire, we've pulled our cable. The next step would be to strip off the covering. And again, it's a non-metallic cover, it's plastic. So we would use a cable ripper to do that. Now we're going to rip 3 inches down. On every single cable. So you rip, and then you can cut that excess